Everybody. So this is day 2 of section 411. A lot of what we're going to do is a repeat of what we did yesterday. So that should be good. If there's any confusion or questions, sometimes you just need to hear it again. So we're also going to talk about simple probability, which we kind of got cut short on at the end of the lesson yesterday. And we're going to do a lot more examples with that laminated card that you have. So before we start our notes, get out your laminated card. If you have a highlighter, that might be useful too as we go through so you can kind of mark on it. So yeah, go ahead and pause. Take that out. Make sure you have a pencil. A lot of what we're going to be doing, you might make mistakes with, or you're going to want to mark and erase. Okay. So we're gonna focus a little bit more on simple probability given different situations, but we're also gonna talk a lot about outcomes and sample spaces like we did yesterday as well. All right. So to start with, we have something that's very similar to what we did yesterday. So this would be a really good opportunity to use as a warm-up. Pause, see if you can answer these, or maybe try to do one, unpause it, listen to me, do the next one, unpause it, listen to me, or just check your answer. Okay. Alright, so if you notice, you have all of these people off to the left. These people, it says the table below displays the food places that each person eats at for lunch. So we have Chipotle, we have Wendy's, we have Panera, we have Jimmy John's, and we have Teddy's. Okay, so Chipotle will use a C, Wendy's W, Panera P, Jimmy John's, we'll say JJ, and Teddy's T. Okay. Alright, so the first one says to describe the event Adrian and Frank. So I'm going to put a little dot over here saying, okay, I'm going to be talking about these two people. Notice that I'm given brackets right here, so that means that my answer will not have brackets. Okay, my answer will be saying like event C, the W, the P, the JJ, the T that I have up above. Okay, so if I look at Adrian and Frank to see if there's anything that they have in common, Adrian likes Chipotle, but Frank does not. Frank likes Wendy's, but Adrian does not. They both like Panera, however, so does Evan, so that doesn't work. They both don't like Jimmy John's, but so does Ben and Evan. And then they both don't like Teddy's, but so does Ben. Okay. Alright, so the answer to this would be, notice that we have Chipotle and we have Wendy's. They're the only two people that like that. So I'm going to say Chipotle. I need to say or Wendy's. I cannot say and because they do not both like Chipotle and Wendy's. So Chipotle or Wendy's. And we should be using this notation. Alright, I'm going to erase this so that I can set up my next problem. Alright, describe the event Kathy and Derek. So here's Kathy, here's Derek. Notice that those two people don't like Chipotle, but so do other people. They don't like Wendy's, but so do other people. Notice they don't like Panera, but so does Ben. Notice that they are the only two people that like Jimmy John's, and they also both like Teddy's. So we could say Jimmy John's, and we could actually stop there and just say Jimmy John's because they're the only two that like it. So there's actually more than one answer. So that's an answer. We could also say that they are the only two people that like Jimmy John's and Teddy's. So either one of those answers is acceptable because they are the only two that like both. Okay, so I'm going to erase this so I can set up the next problem. Alright, describe the event Evan. So here's Evan. Evan likes Panera, but so do other people. Evan likes Teddy's, but so do other people. Notice that Evan is the only person that likes Panera and Teddy's. Okay. So I can say Panera and Teddy's. And just because I'm writing these answers does not mean that there aren't other answers out there. These are just the ones that I'm coming across. Okay. Alright, describe the event Adrian, Ben, and Frank. So, Adrian, Ben, and Frank. So, all three of these people. Alright, well, all three. Well, I can't say Jimmy John's because Evan. Notice that all three of these people do not like Teddy's. So Adrian, Ben, and Frank are the only ones that don't have check marks for Teddy's. So I could say Teddy's, but then that would apply to Kathy, Derek, and Evan. So then I can say not Teddy's. Okay. I could also say, and this one's a little bit more complicated, but I could also say Jimmy John's or Teddy's, because that would be talking about Jimmy John's. It would be talking about these two people. And then if I say or Teddy's, now I'm talking about these three people. So then I would have to say not. And then that would leave me with Adrian, Ben, and Frank. So either one of those two answers. Okay? Alright, let's try a Venn diagram. Number 2 says the jerseys of a basketball team are listed below. So you have 1, 2, 3, 4, 5, 6, 7 numbers. One of the jerseys is chosen at random. Consider the following events. So I have event M and event S. Event M is that the jersey is a multiple of 3. So multiples of 3, just so we're all clear. Multiples of 3 means you have to start with 3 and then add another 3. Oops. Add another 3. Add another 3, so on and so forth. So 3 times 1, 3 times 2, 3 times 3, 3 times 4. Okay? The chosen jersey has digits that sum to be odd. Alright? So I'm going to write those events in here. So I'm going to say that this is my multiples of 3. And I'm going to say that this is my sum to be odd. And then this is my overlap. Okay, so my first number, I'm just actually going to mark it up here before I start going and listing them. So multiples of 3. So this is a multiple of 3, since 3 times 25. 12 is a multiple of 3. 3 times 4, 3 times 3, 3 times 2. 14 is not a multiple of 3, and neither is 11. Okay, before I go place those, though, I want to see if any of these are, I'm going to see which ones are, which jerseys have digits that sum to be odd. So 7 plus 5 is 12. That's not odd. 2 plus 5 is 7. That is odd. 1 plus 2 is 3. That is odd. 9 is just that, which is odd. So if they don't have multiple digits, then it would just be 9 plus nothing. 6 is even. 1 plus 4 is 5, which is odd, and 1 plus 1 is 2, which is even. Okay, so as we go place these in, notice that anything that is just underlined is my M, so that would be 75 and 6. Notice that anything that is just circled is my S, so that would be 25 and 14. And then notice that I have 2 that are both circled and underlined, so that's this middle, that's the and, so that would be 12 and 9. And then notice that there is one event 11 that is not M or S, but is in my list of numbers. Okay, and then I would always double check. So 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. Okay, so once I have those, it makes it pretty easy to, or fairly easy to identify all these lists as long as I know what the notation means. So first one, list the outcomes of not M. The easiest way to go about this is to just say, well, what is M? M is these 4 numbers. So 1, 2, 3, 4, which means then not M would be the other remaining 3. So 25, 14, and 11. I'm going to write them in order from least to greatest, but you do not have to write them in order from least to greatest. It actually does not matter. Okay. List the outcomes of M and S, so that would be the middle, that's the intersection of the 2, so that would be 9 and 12. Okay. And then list the outcomes of the event not M and S. So again, ignore the M and S and just focus on this first. So what is M and S? So M and S would be these two, which means not M and S would be the remaining 1, 2, 3, 4, 5. Okay? Again, order doesn't matter, so I'm actually just going to group together the first two because that's what's in that M. So 75, 6, 25, 14, and 11. Okay? Alright, so if you flip it over to the back, notice that this whole side is all about answering questions with this chart right here. Okay, and that's on the back of your laminated sheet, so go ahead and get that out as well. Again, if you have a highlighter, it might help to actually highlight some of the things that we have. That way you don't lose count. Okay, so I'll show you as we go through. Alright, first question. Consider the event of rolling a pair of dice. So a pair of dice means that you are rolling two of them. Notice that table is talking about two of them. Okay. Part A says, how many ways can you roll a pair of dice and get a sum greater than 9? List them. So, sum greater than 9 means that you're looking here and you're saying, hey, look, these are my outcomes. I can roll a 1 and a 1, a 1 and a 2, a 1 and a 3, all the way down to a 2 and a 6. And then I wrap back around and I say, okay, well now I'll get a 3 and a 1, a 3 and a 2, a 3 and a 3, all the way down to a 4 and a 6. And then I can roll a 5 and a 1, a 5 and a 2, a 5 and a 3, all the way down to a 6 and a 6. Okay? There's product in here and there's sum. So product meaning 1 times 1 is 1, sum meaning 1 plus 1 is 2. Okay, so let's go back and reread this question. It says, how many ways can you roll a pair of dice and get a sum greater than 9? And we want to list them. So a sum greater than 9. Notice that in this first column, none of them are greater than 9. Right? Greater than 9 means that it has to be greater, so it cannot be 9. So the very first one starts right here at 10. So that's where you could use your highlighter and highlight that. So that's greater than 9. And then this is greater than 9, greater than 9. This is greater than 9, greater than 9, and greater than 9. Okay, so we'll go back up and write that. So this first one was 4 and 6. So 4 and 6, and then 5 and 5, 5 and 6, 6 and 4, 6 and 5, 6 and 6. So if I count those, there are 6 ways. So there's 6 ways that I can roll a sum greater than 9. Okay, and this is very important that you list them. It'll help us with what we do later. Okay, next one. How many ways can you roll a pair of dice and get a difference? So difference means you're subtracting. Get a difference that is even, and difference order does not matter. So like if you rolled a 1 and a 3, the difference is 2, not negative 2. So it's absolute value. Okay. And get a sum that is even. Make sure you write this down. 0 is even. So meaning if you roll a 4 and a 4, the difference would be 0, which is even. So how many ways can you roll a pair of dice and get a difference that is even? So you'll notice that you don't need to look back at that card. You can just kind of run through your numbers. But notice like that would be 1 and 1, because that would be 0. 1 and 3, because that would be 2. 1 and 5, because that would be 4. 1 and 6 doesn't work, so now I move on to my next roll, which is 2. So 2 and 2, that's 0. 2 and 4, since that's 2. 2 and 6, and that is all my 2's. So I move on to 3. So 3 and 1. 3 and 3. 3 and 5. And then not 3 and 6, so I move on to my 4's. So 4 and 2. 4 and 4. 4 and 6. And that's all my 4's, so I move on to 5's. 5 and 1. 5 and 3. 5 and 5. and then not 5 and 6, so move on to my 6s. So 6 and 2, 6 and 4, and 6 and 6. And you can see a lot of the repeats going on. Okay? But again, you could look down here, and you could just say, okay, well, my sum is even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then notice if I went up here, there are 6 times 3, there are 18 ways. Okay, and very important again that you write them out though. Alright, let's try again. How many ways can you roll a pair of dice and get a product? So product means we're multiplying. So get a product that is greater than or equal to 20. So the product is greater than or equal to 20. So it can equal 20. Alright, I'm going to erase this so that I can kind of see what's going on in here. Okay, so I'm looking for greater than or equal to 20 for product. The very first one that I get to is not until right here, then here, greater than or equal to 20. So 20 is okay, 25, 30, greater than or equal to 20. So 24, 30, and 36. So I can see that there's 3, 6, 7, 8 of them. Okay, notice that the first one happens with 4 and 5. So let's say 4 and 5, which means 4 and 6. 5 and 4, 5 and 5, 5 and 6, 6 and 4, 6 and 5, 6 and 6, which is 8 ways. Okay, so 8 ways you can roll and get a product greater than or equal to 20. Next one. How many ways can you roll a pair of dice and get at least 1 3? So at least 1 3 means 1 3 or more. So not a product of 3, not a sum of 3, but just talking about your actual outcomes. Well, again, you can look at that sheet, but you're going to get to the point that you won't need to anymore. If you think about rolling, you have if you roll a 1, you can get a 1 and a 3. You can get a 2 and a 3. And then think about now you can get all 3s. So like you could get a 3 and a 1. You could get a 3 and a 2. You could get a 3 and a 3, because that happens to be at least 1, but there's 2 there. You could get a 3 and a 4. You could get a 3 and a 5. You could get a 3 and a 6, and there's all your 3s. But then you can get a 4 and a 3. You can get a 5 and a 3. And you can get a 6 and a 3. Okay, so 2, 4, 6, 8, 10, 11. So 11 different ways. Alright. Alright, last two. How many ways can you roll a pair of dice and get a product that is odd? So get a product that is odd. List them. Okay, so again, we have this down here. I'm going to erase what we have. So product that is odd. Notice that the very first one would be here. 1, 3, 5. A lot of even numbers. And then 3, 9. A lot of even numbers. 15. Over here we have 5. We have 15. We have 25. And that's it. So 3, 6, 9 of them. Notice how they fell. So 1 and 1, 3, 1, 5. So 1 and 1, 1 and 3, 1 and 5, 3 and 1, 3 and 3, 3 and 5, and then I could have 5 and 1, 5 and 3, 5 and 5, for a total of 9 ways. Okay. Alright, next one, last one. How many ways can you roll a pair of dice and get a sum that is greater than or equal to 11? So a sum greater than or equal to 11. List them. So see if you can maybe do this one without looking at your sheet. So if you think about a 1, the highest that you can get with a 1 is a 1 and a 6. And if you add 1 and 6, you do not get to 11. If you think about a 2, the highest that you can get with a 2 is a 2 and a 6, but if you add that, you only get 8. If you think about a 3, the highest that you go with a 3 is a 3 and a 6, and if you add them, you get 9. So not to 11 yet. I'm getting close. You could roll a 4 and a 6, and if you add them, you get 10. So we're going to get to it with 5. So I could roll a 5 and a 5, which is a 10. But I could roll a 5 and a 6, which together gives me 11. So then I could roll a 6 and a 5, because that's also 11. I could roll a 6 and a 6, because that's 12. So there's only 3 ways that you can roll and get a sum greater than or equal to 11. Okay? So your homework is going to be to work on number 2 worksheet. I actually want to go back since I skipped this with both classes. In the last example from yesterday, nope, that's the homework. Let's see. Example 5. Alright. It says an experiment consists of rolling paradise, so it's the same two type of questions. How many ways can you roll a pair of dice so that the product of the two numbers rolled is less than their sum? So notice this is the notation. So the product is less than their sum. Might actually be circled on here already. I'm going to erase it so we can see it. So the product is less than the sum. So if this is the product and this is the sum, 1 is less than 2. 2 is less than 3, 3 is less than 4, 4 is less than 5, 5 less than 6, 6 less than 7, 2 less than 3, 4 equal greater, 3 product is less than the sum. So this is less than 4, 6 is greater 9, 12. We can see we have a lot greater. This is less than 5. That's it over there. This is less than 6. And 6 is less than 7. And that's it. So, make sure that I didn't mess up with this. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer to this was 11 ways. Okay. In part B, how many ways can you roll a pair of dice so that the sum is odd? So sum is odd. Oops, odd. If you want to write it out to some degree. So the sum is odd. Oh my goodness. Let's see. Erase all this. Alright, so that the sum is odd. So notice that we have odd, almost every other one. And then sum is odd. And this is again where a highlighter would be nice, even if you could just put a dot next to it so that you could count it. So if you could do something like this with a highlighter, and that way it's less to have to erase. So if we go back and count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 ways that the sum is odd. Okay? Alright, your homework, go back forward. Oh my goodness. Alright, so your homework is worksheet number 2. Again, a lot like your homework, you'll have a table where you have to describe the events. You'll have a Venn diagram with letters and numbers. You'll have another table where you're given all of these events and you have to list all their outcomes. And then you will have 6 questions on rolling dice, which we just had, 6 or so with them as well. Okay? Again, notice that it says to list the outcomes. You are not just stating a number, you need to actually list all of the outcomes, no matter how many or how few there are. Okay? Alright, I'll be back on Wednesday. I'll see you guys then.